Hi, I'm Chris and welcome to part 3 of our vector series. If you haven't yet taken a look at part 1 or 2, part 1 covers an introduction to vectors, some of the terminology associated with vectors like magnitude, head, tail, angle, direction, and things like that, just to get a basic idea of what vectors are all about. Part 2, we talk about the distinction between directions when you talk about north of east versus east of north and what that might mean in terms of drawing out your vectors and assigning the appropriate angles. And now we're going to take a look at calculating the different components of vectors. You're going to have both horizontal and vertical components of your vectors. So we'll talk about how we go about finding those out. The way that we're going to do that is by using SOHCAHTOA. And hopefully that's something you remember just from your math class, even before being introduced to it in physics. But if not, you might want to take a look at the link below and take a look at our video on SOHCAHTOA, just so you can get a basic understanding of how to use those trig functions and what the proper trig function is to use when given certain sides of the corresponding right triangle. So for this vector, we see here, this is going to be mag for magnitude, and this symbol here is theta, which is, it's basically the variable for an angle. Just like for a lot of variables, we use x or y or a or b. For angles, we use theta to represent an angle. So for this first vector, we're going to look at a vector with a magnitude of 10 that is directed 50 degrees north of east. Okay. So if we remember from our first video on vectors, magnitude just refers to the actual numerical length of the vector itself. So it's basically like saying that this vector has a length of 10. It might be 10 inches or 10 feet or 10 meters, whatever the case may be. And later on in physics, you'll probably get introduced to vectors that represent different ideas other than length, such as force. And it might represent 10 newtons. Or 10 pounds of force for that matter. But for right now, we're just going to use just numerical values. We're not going to worry about the units. So this is a vector of magnitude 10. And then the direction, 50 degrees north of east. So if we remember from part 2 on vectors, when we talk about north of east, that means we're comparing this to an original heading in the east direction, which would be directly to the right. And then we're going to veer from that east direction 50 degrees towards the north, which means this angle in here would be our 50-degree angle. So for the components of our vector, we're essentially going to be looking at the horizontal and vertical components. And the easiest thing to do is basically to make a right triangle out of this vector shown. So this would be a right angle here. And we'll call this down here, I'm going to use a little arrow to indicate that we're looking at something where direction matters. So we're going to have, we'll call it Vx and Vy. For right now, I'm just using V arbitrarily. Let's call it V for vectors. But in a real word problem type situation in physics, V might represent velocity, or you might have F for force and A for acceleration and things like that. And then you would see the component parts would be Vx or Vy or Fx or Fy if it were force, or Ax and Ay for acceleration. For right now, we'll just think of it as a generic V for vector. So in this case, we want to find what that horizontal component is. So we'll start with the horizontal component, and I'll put my calculations here. So Vx. How are we going to solve for Vx? Well, if we take a look for our right triangle, we're looking for this side, and we know the value of this side. So compared to this angle, if we think SOHCAHTOA, sine is your opposite over your hypotenuse, cosine is your adjacent over your hypotenuse, and tangent is your opposite over your adjacent. So from this angle right here, the 50-degree angle, we're looking for the adjacent side, and we know the hypotenuse. So which of our trig functions relates adjacent and hypotenuse to each other? Hopefully when looking at SOHCAHTOA, we can recognize that that is going to be the cosine function. So in this case, the cosine of 50 degrees would equal your adjacent, which is Vx, over your hypotenuse, which is 10. Cosine 50 degrees equals Vx over 10. And if we want to solve for Vx to get Vx by itself, a little algebraic manipulation here, we can multiply both sides by 10. So Vx our horizontal component of this vector will equal 10 times the cosine of 50. And that's something that you can use your calculator to calculate the exact decimal value if need be. Now, for Vy, I'll color code it a little bit. Actually, let's put Vy in red just so it's a little bit easier to follow along with. So here, for Vy, we're going to do something very similar when solving for Vy, except if we look at our triangle, this side here, this is opposite the angle, and we know the hypotenuse. So we're looking for the opposite side. We know the hypotenuse. Which of our trig functions relates the opposite side and the hypotenuse of a right triangle to each other? Hopefully, looking at SOHCAHTOA, we see that that's sine. So you're going to have sine of 50 degrees equal to your opposite side, which is Vy, over your hypotenuse, which is 10. And just like we did on this one, we multiply by 10 to get Vx by itself up here. We multiply by 10 to get Vy by itself down here. So you're going to have Vy is equal to 10 sine 50 degrees. So now we have both components of this vector. This is the horizontal component, this is the vertical component. And the reason that's so important is because when you have multiple vectors, to find out the resulting vector that you get from piecing them all together, you're going to have to take the sum of all of the horizontal components of each individual vector and all of the vertical components of each vector to create one large resultant vector when you have multiple vectors. And that's what we're going to take a look at in the next part of our video series on vectors. So for questions, please feel free to rewatch this video or any of the others so far. You can also check out our website for more content at sandersontestprep.com. The link should be in the description below. Thanks for watching.